Hello, welcome to another class with Physics Anchor. We have a JAMB past question on the board being sent by a student. So we want to solve this so that other students also can benefit from this. So the question reads thus: three capacitors of capacitance 2 microfarad, 4 microfarad, and 8 microfarad are connected in parallel, and a potential difference of 6 volts is maintained across each capacitor. Okay, the total energy stored is dash. So they want us to calculate the total energy stored. So if you want to actually see the network diagram of this, you can actually sketch it. So you don't have to sketch it if you know what you are to do. So I just want to show you so that you can have a clearer view of what it looks like. So they are connected in parallel. So the three capacitors are connected in parallel. So you are going to have something like this, something like this. So they didn't give us a diagram. I'm only sketching so that you can see. So we have 6 volts across each of them. So by analysis, the three capacitors are connected like this. 4 microfarad, and we have 8 microfarad here, and these are 6 volts. So because they are connected in parallel, so definitely we know that what the potential difference across them will be what the same. So there is 6 volts across this 8 microfarad, there is 6 volts across this 4 microfarad, and there's also 6 volts across this 2 microfarad. And we know that in a direct current capacitive circuits, we have the energy which they are asking us. The energy, okay, is actually half CV squared. Okay, we can use half CV squared. You know that the fundamentally it is actually half QV, but because our Q, okay, has a connection with C equals to Q over V. So you can actually represent your Q as a Q equals to what CV. So if you put CV to replace what Q here, so the formula becomes half times CV, which is this Q, times the V that we have here already, which will give you E equals to what? That's the energy, half CV squared. Okay, so it can be this, and you know why it is actually what? Half. That's because we are using the average potential difference across the two plates of the capacitor, because the capacitor is actually charged from 0 volts to final volt. Okay, so the final volt, let us represent it by what? V. So if you are going to find the average, okay, it is actually charged from what? 0 volts to what? Final, volts. That was going to be, that's to final volt, that's going to be 0 plus V divided by 2. That's what? V over 2. Okay, and then okay, that energy is actually what? QV, but because you are using what? The average potential difference, so it's going to be half QV. So the formula can transform to this, and in some cases you can also have your V equals to Q over what? C. So that means that if you also put Q over C for V here, it's going to give you E equals to half, okay, Q, okay, times this V, which is now Q over C. So the formula can also give you E equals to half Q square, okay, over C, which can give you Q square over 2C. So you can also have the formula as this. Okay, so anyhow, depending on the parameters given, you will know whether you are applying this, or whether you are applying this. So in this case now, because we have the capacitance and we have the what? The voltage. Okay, that's the potential difference. So we know that we are actually what? Using this formula. So they want us to find the total energy stored. So if we must find the total energy stored, definitely we must find the total capacitance in this what? Arrangement. And because the capacitors are connected in what? in parallel. So we know that what the total capacitance will be 2 plus 4 plus 8, and that will give us a 14 microfarad. Okay, because this is the how you connect the parallel what, how you combine rather the parallel connection of capacitors. So this is very important. So now that we know the C total, so we can put our C in this place, and we already know our what, V, which is what, 6. So total energy now equals to half times C, the total capacitance, times what, V squared, and that will be equals to half times total capacitance is 14, and then our volt is actually 6 squared. So that can give us 2 here 1, 2 here 7. That will give us 7 times 6 squared will give us 36. Okay, and don't forget that the capacitance we're actually using here is actually 14 microfarad. So to use it in farad is going to be times 10 raised to power minus 6. Okay, because the unit of capacitance must actually be what, in farad. So if we have 14 microfarad, we're actually using 14 times 10 raised to power minus 6 what, farad. But if you check your option very well, you can see that what they make use of it. So it's very important for you to put this times 10 raised to power minus 6, so that you are going to be working with what, farad. So we have 7 times 36 now times 10 raised to power minus 6, so that we are working with capacitance in farad and not microfarad. So that will give me 7 times 6, 42, remainder 4 times this 21, that's 252 times 10 raised to power minus 6. So let's check the option. The option is being left in a standard form. So let us take this 1, 2. That will be 2.52 times 10 raised to power 2 times 10 raised to power minus 6. That will give me 2.52 times 10 raised to power 2 minus 6 will give me minus 4. Minus 4 what? Joules. Okay, 2.52 times 10 raised to power minus 4 joules. So let's check the options. A will be the correct option. 2.52 times 10 raised to power minus 4 joules. So it's very important for you to actually understand the background. You have to have this background analysis, okay? And another careful thing you have to do is that be checking your options. I've actually explained this in some videos. The smart way when you are writing JAMB is that check your option first before you work. Because I was actually working. Okay, so looking up, there are some questions like that they will not even convert this micro, okay, farad to what, farad. You will still be seeing it reflecting, especially when you're working with charge. If it's question on charge that they ask you, they can leave the options as micro what, coulomb. So which means that what, you may not have to what, convert, because you have to be fast, because you are writing what, JAMB. But in this case, they actually make use of it, seeing everything being left in standard form. Immediately I know that what, I'm working with what, farad. So we have to multiply by 10 raised to power minus 6 because of that micro there. Micro there is 10 raised to power minus 6. Okay, so multiply times 10 raised to power minus 6, and then you arrive at this. So this will be the final answer. And then having checked it, we see that what, A is the correct option. I wish you all the very best in your examination. Share out this video, like, comment, and subscribe if you have not done so. Bye for now.